Sorry, Mr. Jens, can you please try to advance?
It's not working.
Okay, it's now. Okay.
Oh, no, here we go.
Can you go back to the first one?
I'm trying. Click slides. I'm not in control, Lucy, right? Am I?
Just a second, I will. Can you please control it now?
I try. Give me a second. I go up, down.
Okay. We are ready, I guess.
Okay. So it's already 11 o'clock. Good morning, everyone. A warm welcome to all of you and who have joined us today. This is day 5 of Coimbra Sustainability Summit, and we have 4 sessions today. And our session right now is focusing on the manufacturing sector. Let me quickly introduce myself. My name is Jens Strücker. I'm a professor for energy management in Frankfurt, Germany, and I'm an information scientist and economist by training. So my team and I, we work at the nexus of IoT, energy, informatics, and green information systems. That is, we want to understand how technologies as IoT, AI, or blockchain can contribute to achieve environmental objectives. So our vision of the summit is, let me just go on with the slides. There's a little delay here.
Please
Can we have slide 2? It's not working.
click with the mouse over the presentation, and after that, the arrow.
I did.
Okay, so I'm back in control. Can you try it now, please?
It's not working.
Okay, so.
No. Thank you. So maybe you can, I call you and you.
Yes, I'm here.
Very good. Yeah, our vision for the summit is to understand how the Sustainable Development Goals from the United Nations and the Green Deal from the European Union could inspire technology right now to create new value for our society. And so as agents of innovation, we need to do our part in addressing the challenges the planet faces, and at least try to address some of the 17 sustainable development goals, the SDGs, so-called, defined by the United Nations and the Green Deal. So we would like to debate with you how new technology interceptions such as AI, blockchain, IoT, Internet of Things, and cybersecurities, the so-called 4 KETs, can support decent work and economic growth by creating new partnerships to achieve those goals. So the topics that will be covered during 2 weeks of the event, of the summit, are health, agri-food, manufacturing, and sustainable cities. Please go to slide 3. Thank you. So on board, we have representatives of diverse stakeholders, inspire leaders, researchers, companies, such as the speakers we have today on our panel, investors, and of course, European Commission, who also have a very important role during the summit. Please go on to slide 4. So these are the goals: inspire innovative approaches, because we think that the new innovative approaches facilitated by the use of the aforementioned technologies, blockchain, IoT, and so on, can deliver better value to the society. We want to encourage and create new partnerships, so you are invited to connect to other participants. Slide 4, please. 5, please. So the summit is supported by 4 European Horizon 2020 projects. The main sponsor of this initiative is Diatomic. Diatomic is a network of digital innovation hub that aims to establish a sustainable ecosystem to facilitate microelectronics and smart system integration, innovation in 3 sectors: health, agri-food, and manufacturing, all of which are under digitized, as you all know, and are of prime importance for society and the economy. So the other projects that are supported, that are supporting CSS are blockchain innovation spaces. Block.is aims to build an open and collaborative cross-border, cross-sectoral innovative ecosystems that fosters the use of cutting-edge technology in 3 vital sectors for the European economy. Again, agri-food, logistics, and finance. Then we have Enrich. This is fostering the collaboration between the US and the European Union. And we have multi-layered security technologies to ensure hyper-connected smart cities with blockchain, big data, cloud, and IoT, AMSEC. And all of these projects have the goal of supporting SMEs on the digitalization field. So slide 6, please. So the CSS, the cycle of webinars, has been split into 2 weeks with distinct topics. During the first week, the plenary members and attendees will focus the debate about the assessment and the needs for the 4 sectors, emphasizing the dialogue on the importance of the SDGs and Green Deal, ethics, and partnerships for the definition of solutions. And the second week, which we are part of, will raise the needs leveraged on the previous week and invite technological companies to provide their testimonial on how they are using the intersection of the 4 KTEs to create value and to understand how the digital transformation will support our quality of life over the next 10 years. So Diatonic, our main sponsor, is the host for the debate today about bridging the gap to how the intersection of the 4 KTEs will support the needs of the manufacturing sector in the next 10 years and leveraging of the technologies to create better values in this sector. And until the end of CES, attendees will have the opportunity to participate on the final public policy and funding opportunities plenary on May 29. And this session aims to present the position of public policy and its links to sustainability and the Green Deal, as well as various public funding opportunities that will be available until the end of the year. So I think this is important for all of us. So before we start the presentation, some final remarks. Don't be confused. The chat is disabled for you. We will have 15 minutes presentations followed by a 5 minutes Q&A block. And could we switch to slide 9, please? Or the next slide, sorry. I'm glad now. Oh, you can go back one slide. Thank you. I'm glad to introduce our panelists today who have joined us, and we are very glad to have them here. We will start with Stefan Büttner. He is Director Global Strategy and Impact at the Institute for Energy Efficiency in Production, EEP, and chairs the newly established United Nations Economic Commission for Europe, Task Force on Industrial Energy Efficiency, and as initiator of a global policy and industry benchmark called the Energy Efficiency Barometer of the Industry. He facilitates demand-side informed efficiency actions. And Stefan, I think you will start now, and yeah, the floor is yours. Thank you.
Thank you very much, and good morning to everybody wherever you are. Following on the conversations we had before at CSS, learning about the challenges, the opinions, and the solutions in principle, I'm going more into the how we can it actually make happen. It being the transition of the manufacturing sector, the transition towards a world where we are getting rid of emissions as much as possible, to a world that is sustainable to allow us to continue as a society for the time being. It always takes a little bit until the control has switched. It should work now. Okay, here we are. So I'm going to tell you from various different dimensions on how we can make happen on the ground. And for that, I'm going to give you a quick journey across several different areas of action and move from the analog side increasingly towards digital solutions in making this happen. So first of all, what can be done in principle? We have, most of us at least, heard about cross-sectional technologies, and there are many graphs such as this around, indicating the potentials of the different technologies. However, these are only resembling relative improvements within the technology field itself. For example, lighting, you can save about 70% in doing efficiency improvements in lighting. However, lighting only makes up 2% of the industrial energy consumption. So therefore, the impact of other means is much, much bigger. So there have been multiple studies on what could be done, what would have big impact. There are studies in Britain, studies in Germany on how market-ready innovations that are already out there can increase potentials and allow us to reduce costs and to make better use of the resources we have. These innovations differ quite drastically by the return on investment, by the cost of getting to know how to implement them. So therefore, I'm not focusing on the heavy lift, which would be the high temperature heat pump with the largest single savings potential. I'm focusing more on what can be done by just being smart about it. And that is optimization of network systems, energy systems, local energy systems, finding out what you consume, finding out where you consume it, whether you actually need to consume it at that point, and also how you can make it happen not to consume anymore. Once you have understood as a user the principles, you then can enter the second phase, which is trying to automate that, trying to get digital assistants and machine learning, AIs, etc., that help you to do that. But first of all, it's the human being that needs to understand the principles where you actually need to touch base first. And how you do that in principle in plants is 4 basic intervention points. The first one is its adjustment of installed power. The second one, the control technologies. There, for example, if you look at buildings at your own homes where you have potentially heating systems. You get them installed, you get them set at the first instance, but do you ever change the settings to the use? That hardly happens. And there's the point where you can actually make the big savings, which is also leading to the optimization of process parameters and making use of further energy losses or unnecessary resource losses. That can be done to optimize standby consumption, production consumption, and output. Now, some quick examples. You will have access to the slides afterwards, so I'm going to be quick about them, just showing you the principles. So how do you adjust installed power? You need to understand what the consumption is at the moment, and here we did that with a 48 channel long time measurement of power consumption in the plant. And essentially, the findings were it is more efficient to have two 100 kilowatt torque AC torque engines rather than one 260 kilowatt DC engine, allowing us to reduce not only energy costs, but also acquisition costs. It's like having a car with a big engine or an electric motor at each of the wheels. The second one is optimization of the control technology. Imagine how we have the power peaks in households in Europe, in principle, in factories everywhere. When you switch everything on at once, you have a huge power peak and your grid connection or your installed load is optimized for that interval. However, it's not necessary that you switch on everything at once in most cases. And there, in this instance, cascading the starting time of the different engines and then switching it off during setup and standby allowed us to not only reduce the load peaks, but also the standby consumptions dramatically. In the efficiency barometer, we also found that 3/4 of companies have no idea about the standby consumption, and there are still many engines that are either on or off. They don't have an energy savings mode because of the greasing cycle that is necessary. Another means is the optimization of process parameters. And there, for example, it is a means of finding out how do you get the same result with perhaps a shorter process time or a different temperature. Here you can use the example of baking bread, where you may be used to a certain duration and a certain temperature, but maybe you can get a higher output or save energy when you have a shorter period at a higher temperature or the other way around. So in this example, we were also able to save a third. What can you do as well? We also have the situation of increasing temperature and increasing needs to cool equipment, not only IT equipment. And in contrast to the development of overall electricity consumption, we see these peaks. The one of cold consumption is gradually increasing for different applications, cooling, air conditioning, etc. So what can be done there is understanding that refrigeration systems are often oversized to cover the peak loads. And mostly they run in parallel load. So the machines have a certain base load that is catered for. It's often catering for personnel and the need for personnel that cause these additional cooling needs. So there, if one has the data, there are means to find another approach that is more efficient in finding the solution for the issue. But what are the future concepts for industry that we have started using now? They start with some questions. How far do you want to go? What is the ideal mix based on your circumstances, on your sector, on your technology? What are the key factors that you want to optimize for in terms of environment? That is not only the nature environment, but also your company's environment, the expertise to hand, the investment cost or the cost ratio, the priorities in management, as well as the individual needs. And there we have renewables, efficiency, flexibility, storage system, and smart grid solutions. And I'm going to give you a quick dive into each of those fields, indicating where it could go. Where it could go when? Right now, when we have COVID-19, or afterwards or before, the system is changing quite a bit. And when this sad development of the pandemic is really causing lots of harm to many people across this world, there are also few positive aspects, and that is that the workforce and the individuals are in many cases confronted with digital needs from their employers, at school, everywhere, and therefore this ad hoc confrontation pulls down barriers and uncovers shortcomings in the systems, in the preparedness. So therefore, people are forced to get used to it. This is a big opportunity, because also when we touch first base with Facebook and the lot, it took a critical mass for it to succeed. And having now the situation, going to work in a virtual office or have virtual meetings is becoming more and more common. The resilience and flexibility of business model and supply chains are now more in the center, or should be, because one can either be prepared and utilize the time to think how one can innovate, improve the business model, or just hope for it to be over and survive as a business. It's not so much in one's hand in all the circumstances, but in quite a lot of them. Creativity and business-mindedness can pay off right now. Here comes in the chance for automation and AI. For example, it helps us to keep operating when keeping distance. It helps us to develop routines to remote control rather than to have physically to flick switches. It enables us to see the relevant information within the big data, and it helps us finding solution to multidimensional optimizations, such as the measures mix I just showed you. However, it also is and should, and that needs to be our key point here, also is that evolving the workforce to oversee the bigger picture, to determine what matters in the thick data, something that digitalization cannot lift us off, at least not yet. So I'll start with this example, digitalization of leakage management. Compressed air is one of the applications that is utilized quite widely, but if you have leakages in the system, you lose lots of potential, and you may have bigger compressors than you actually need. There, one of the projects is to identify different means, in this case, 200 different means, to automatically identify leakage reasons, to identify the status recognition with cameras and AI-based pattern recognition. Now, if you scale up a bit from the individual application to the bigger picture, we're looking at the future concept where we have efficiency on one side, effectiveness on the other, so marry the two impossible elements, but also add flexibility to that. The more flexible, the better. Why is that of importance? When we have to integrate fluctuating generation from increasing amount of renewables, when big energy users such as steel companies or aluminium manufacturers weigh about 2% of the nation's electricity consumption, they are a big burden to the grid. However, they can also be a big opportunity, which we'll learn later. So the aim, the long-term aim, is to transition towards something that we call the ultra efficiency factory, where all input factors are used in the product, where there's no scrap, no emissions, and no waste. Examples for that you see here and on the next slide, taking a picture of the good that you need a case for, and then the AI and the system behind it allows you to tailor that. Even if you have the lot size one, there are applications from big companies that used weeks to tailor solutions for their clients. However, these days, they just go there with their smartphones, take a round view, and then their system allows them to precisely simulate and plan out the solution for the client. Another one is to utilize, for example, concrete pillars and smarten them up to not only stabilize the building, but also to activate the ground beneath the building to store energy that is surplus energy. Talking about storage. Storage systems, batteries are a big opportunity, but also challenge. And there are so many different types of batteries. Short-term batteries that have lots of capacity, but not so much load, and the exact opposite way for different means. So with batteries, we also have the challenge of what do we need it for and how do we manufacture it. So here, before actually applying it, before manufacturing it, it's a matter of finding out what to use it for, and therefore to simulate the demand, to simulate the utilization. And that's what we call a virtual twin, a digital twin. But rather than in the past just focusing on manufacturing, now also focusing on acceleration of innovation and time, which reduces the cost and increases the flexibility of the system to allow us a closed loop where the factory or the also considers disassembly of the product in the end. When we talk about storage, we also need to talk about DC, direct current rather than alternating current. With DC, it's possible to smarten up the local grid, the industrial smart grid, because it allows you without additional input to feed in renewables without converters, to feed in storage, and to connect things up with each other. Also to share and transport data without the need of additional infrastructure, which leads to higher reliability, expandability, and an integration of flexible loads. On this slide, you could see a video demonstration when you go back to it. But in principle, what can be done? You get a higher robustness against outages if you use it, for example, in such an assembly line. There's also another example with a car manufacturer that combined 3 robots with each other that lift and put things down. And just by connecting 3 robots with each other, they save 1/3 of the energy. Talking about storage and flexibility, there's also something called virtual storage. As said, we do have fluctuating energy supply due to renewables. And how do we make the system ready for such renewables? There, Germany has come up with so-called Copernicus projects to accompany the energy transition. One of them is about the industrial sector. Why is that? Because the industrial sector makes up 45% of Germany's electricity consumption, and that is before any decarbonization efforts. So how can we utilize or make use of the heavy weight of industry to serve as compensator rather than being forced to spend 1.5 billion euros a year to compensate those that can't feed in their electricity? So what are the synchronized and energy adaptive production technologies where the processes and the algorithms, you can see more if you click on that video, are actually identifying the ideal point of intervention and then do one of those flexibility measures, such as change of source of energy, pausing process, shifting idle times, or storage of energy. Applied on the refrigeration example earlier, that could be shifting the consumption at times of high renewable energy production to earlier or later, reduction at the peak load times by cooling it down whenever there's surplus a bit more, so it lasts longer, increase the consumption, which is what I just said, when there is a surplus, and also changing the load curve spontaneously. Why is that a good thing? Because it allows us to reduce the need for single-purpose battery storage and compensates fluctuation in the grid. Also, it provides energy security. This is of relevance because, for example, there's one aluminium company that is responsible for 2% of Germany's electricity consumption. If they flexibilize just one of their aluminium smelts, they can already they can buffer store, virtually store 1 gigawatt hour over 48 hours. And if that was applied across the board in all aluminium smelts in Germany, that would save as much as a third of the overall pump storage capacity of the country. And that's just the electrolysis process in this one industry. Imagine if that was scaled up. But there's more, and that is best described with this statement, that the biggest innovation of the 21st century will be the intersection between biology and technology. What does this mean? This means designing biointelligent products that take information during the use phase and that are able to be ecologically sound in their disposal and to be refabricated with a feedback system. So what could this mean? Decentralized manufacturing via smart biomanufacturing, better resource and energy utilization, and highly efficient concepts. These can be applied to new materials, biotech interfaces, manufacturing technologies, data processing, many different fields, also medicine. And that brings us to the next topic. Imagine the fact that in many instances, there's data gathered. There's data gathered for specific use cases that depend on the mixture of machinery that you have right now. But what happens if you change machinery? What happens if you lose that person who is able to read that data? What would be, if it was possible, much easier in a way where you have something like in home automation today or with smartphones, where you have one operating system that works as a base and the skills of the hardware are integrated. Imagine we had such something for manufacturing where skills of the machines, such as sniffing sensors for quality, such as energy sensors for consumption or resource utilization, would be automatically feed back to a central something that would allow you simply to utilize a dashboard. And same thing with cybersecurity, tightening the processes up so that they're hack safe, because that's the downside. There's far too many innovation not thinking of the evil that is trying to find loopholes and able to sabotage things. And I'm glad that we'll hear a bit more about something that could promise the way out of this conundrum, and that is FabOS, that I believe Daniel is telling you a little bit more about later. But I'm keen to see the energy skill put onto that. So with that, I shall end. And somehow the control already left me. And I thank you very much for your attention.
Stefan, thank you so much for your presentation. I think I have a couple of questions. Maybe I start with the following. You talked about the potential of technologies like AI for energy efficiency. So this means, of course, we all know that with neural networks, etc., we can optimize processes. We can improve them. But for me, the question would be, what comes in your mind at the first place if you think about more effective ways to do things differently? So this means not just to come up with a improved process, but do it totally different. So for instance, you talked about compressed air. So finding leakages is one thing, but controlling things differently, maybe that's a way, or what would you say?
There are 3 points. Number one, it's like with academic papers or ambitions, they're interesting, nice to have things, and they're neat to have things. So one can easily get carried away with things that are too far off. As for general approaches and specific solutions, I think a mixture is of the essence. So with the compressed air example, we do need to find ways to, in general, identify issues where such systems and algorithms can be quite helpful, because otherwise you need experts that have an eye for that have developed an eye to see issues. If that skill was transposed to something automatic or could be learned by an AI, those skilled personnel can focus on training AI and focus on the next bigger level of integration where everything is linked with each other. But then one will very quickly find applications, such as in the cooling example, such as in the compressed air example, where you actually need to find out exactly where the issues are. So one is the element of creating the necessary data, and the other one is the element of reading that data. And the reading that data I put on my slide as thick data. Thick data is a concept where you do mix the big data with human intelligence of being able to assess and weigh information and mix it with the real world to put context to it. And this mixture is of large relevance. As for the compressed air example itself, we are just at the beginning, but I'm glad to say that we have a whole unit that is focusing on digital means of exploring exactly what you requested, what you asked. And on the policy and system side, I'm glad to say that as of last week, there is a working group within the United Nations that is looking at different elements of digitalization. The 4 ones that you mentioned: the role of AI, blockchain, IoT, and cybersecurity, and how this can be made best use of from a policy side, but also from an application side, because these sides need to understand each other. Otherwise, we'll have policies that are not catering for the actual needs, and vice versa.
Thank you. Makes a lot of sense from my side. So I just want to tell everybody, the audience, we have, if you look to the bottom of your Zoom screen, you see a little button, a Q&A button. So you can press it, and then you can raise questions there. And already now, you will have plenty of opportunities to raise your questions later on. But right now, if you have a question, urgent question to Stefan Bittner, please write it down. It will show up then. Thank you. So meanwhile, Stefan, just a quick one at the end. So for me, if you look at the end-to-end automation process, digitalization is always also about end-to-end things. And if we look to data networks and Industry 4.0, what would you say is where do we need more? Where's a gap today, an urgent gap, where we would say, okay, here we need a piece of technology, or here's something missing, and it's very urgent. So, do you see identify something?
Digitalization doesn't mean that you have to buy everything new. In our application center, we have machines that are 50 years old and they're smartened up. That's one thing. The other thing is we must not forget about the small companies and those that do not normally have to replace their systems regularly. These are the ones that could benefit potentially a lot. However, it's not their daily business, so therefore they have difficulties making use of these potentials. So therefore, those companies, particularly the smaller ones, smaller meaning the companies between 0 and 50 employees, are the ones that require help, lots of help. That doesn't necessarily mean financial help, more advice on how can I do something. Something like the efficiency networks idea, but more focusing on digital innovations. There is programs such as the I4KMU, which is SME, but these need to be married with actual applications, actual needs. So what do I digitalize for? Do I optimize output? Do I optimize the product, reliability, or energy use? And that's the key element.
Thank you.
Having one platform where you can actually slot all that in rather than having many things that cannot be connected with each other and speak different languages, technically speaking.
I think we will have time to talk about this on the panel later on. And this brings me to, thank you, Stefan, first of all. And this brings me to our second speaker, Daniel Stock. He is Director of Global Strategy and Impact at the Institute of Energy Efficiency in Production.
No, that was Stefan,
No,
I think.
That was Stefan.
Sorry?
That was me.
Oh, sorry.
I'm just a mere group leader here.
Okay, so this was my fault. Sorry for that. But you will talk, and this is how I know you, you will talk about the FAB operating system, FAB OS, yeah, of course. And there we have the direct connection between the two of you. And FAB OS aims at developing the IT backbone for the versatile automation of the factory of the future, and the foundation of an ecosystem for data-driven services and AI applications. And yeah, I'm very excited, and I hope we will get a lot of insights now. So go ahead.
So hello everyone, from me too. Thanks for having me, and thanks for your interest. Stefan already introduced a few of the topics and the problems in manufacturing, especially regarding applications for energy efficiency. And this is basically also one of the blocks we are looking at, but we want to basically improve the whole concept of how we bring these new AI application into the factory. And do I have already controls? No. Okay, now I think it works now. So, and this is why we thought of this concept of a factory OS or FAB OS. You can visit the website meanwhile or afterwards and have a look on the information we have there. The project started just in February, and but there was this AI innovation competition from the Federal Ministry of Commerce in Germany, which has been started in the beginning of last year, and we applied in this competition and provided a proposal for the first phase, where selected in the first phase to develop a concept for this FAB OS. And from the second phase, we were also one of the projects which have been selected for funding. And our now the phase where we take this concept we developed last year and implement it is started in February of this year. And here's our basically our slogan. We want to be an open, distributed, real-time, capable and secure operating system for production. This means we want to do everything basically which you need for production, but these claims need to be explained a bit. So open means, of course, we want to be open so that we don't want to create vendor lock-ins. We want to work with open source software and applications which are getting more and more popular also in with other companies or larger companies and also smaller companies. I think if you look at any dashboard now in a web application, for example, also what you can see, this COVID dashboard, which shows the number of cases which everyone is looking at. This is made in Grafana open source software, and these are softwares which can be used for these applications or also easily in factory applications. And distributed means that we, of course, use cloud technologies, edge cloud technologies. So this is the modern approach nowadays. Like in 2012, did all this cloud hype started, and companies wanted to use cloud applications. Nowadays, we use a lot of cloud applications, but what we noticed in the last few years that especially for real-time capable applications, we need more edge cloud-based architectures, which is also a concern of HepOS, and of course security regarding functional security, safety, and of course information security is a concern which needs to be taken care of in a factory operating system. So can we switch to the next slide? Thanks. So what are the main challenges and what's our solution approach? So the key challenges are, of course, that we want to increase flexibility. This is something we saw recently in this COVID crisis. Many companies started switching their production to medical technology to produce like face masks and respirators, and these are scenarios which became very real. We of course always talked in previous projects in the last years about increasing flexibility in production, improve manufacturing automation technology, and so now we saw that this is actually a real use case which can happen, because sometimes in the past companies said, yeah, why would I constantly be changing, or why do I need this extreme kind of flexibility? Well, now we see it, and there will be also upcoming projects. Also the new Horizon 2020 special funds are now related to creating like more flexible productions to be able to react to changes in a crisis like this. And also, since this is a project very much focused on artificial intelligence, which is an important topic nowadays, we want to be an enabler and create a platform for industrial applications for artificial intelligence, which is one of the main goals of our government, to keep the technical sovereignty of our companies in Germany. And this is also something which we want to do by creating a platform for companies where they can build their industrial AI applications on, because the applications used by consumer or by companies providing consumer-oriented AI applications, this is something which is, I would say, very much on the side of large companies like Google and Amazon and Microsoft. But we see our big chance to bring all the knowledge and the technological sovereignty we have in our strong German industry into this industrial AI field. And another challenge is, which was also a bit mentioned already by Stefan in his talk, this problem with integrating all the data, for example, to track all the data and information you need for the energy efficiency. And this is something which is caused by this heterogeneous system landscape of ICT and production technology, which we want also to tackle with the approaches in FabOS. So, and our approach is to build, to create a new IT architecture or a reference architecture of how ICT and OT, operational technology, can be brought together in a factory, but with the specific goal to enable AI technology and an AI-based production. For that, we want to use a lot of the modern technologies, so edge cloud technologies, virtualization technology, a lot of the functionality which has been built in the past and created by special hardware is nowadays put into software-defined systems. One example is the 5G architecture and technology, which is much more flexible and also less expensive due to the fact that many of the functionality is not created by specialized proprietary hardware, but it's basically off-the-shelf IT systems which are using software-defined functionality, and this enables a lot of flexibility in this communication technology, and also makes it much cheaper and widely available. And similar concepts should be applied to operational technology, which is already being done in small spaces, and we want to bring it together. And we want to bring it together on this FabOS platform, which follows like principles of an operating system. So we call it FabOS operating system, but you cannot expect it to, or you shouldn't expect it to be like Windows XP for your factory, that someone will come to your factory and bring a DVD with FabOS on it and install it, but it's basically tying together all these components we have been developing over the last years, and those are of course platforms, applications, and various technologies, virtualization technologies, and we want to tie them together. As I mentioned, we want to bring together OT and IT, which is converging more and more in other areas. And in this case, we want to show which of these applications we know from other areas, especially cloud technology and things like communication technology, how it can be applied in OT. And there we see new possibilities, but we also see new challenges, and especially how to apply this in a context that we can bring it together so that companies can also use it. We have to think about SMEs, we have to think about users in the factory, which is also an important topic in our research project, how to enable also smaller companies to adapt this technology, and not only larger companies who can do it by themselves. And as I said, basically FabOS is like a platform operating system, and if you look at how these ecosystem structures and platform structures developed, so we have this platform, various platform technologies, and which bring together people. So this is something like these Apple iOS platforms with their application store, and then we have production technology platforms, something like Adamos IIoT, or Exum, or other platforms. Also, Microsoft is now collaborating with Volkswagen, and no, it was Microsoft is collaborating with VW, I think, and no, with BMW, and Amazon is collaborating with Volkswagen or something like this. And there we see that these larger American companies are now trying to get into our manufacturing business. And this is where we say, and where also all the governments, that we would like to position something which brings our technology and our manufacturers together, so that we keep the technological sovereignty on our side of the pond, so to say. And this is where basically this extra layer of artificial intelligence comes in, and there we have like three main topics for our research project. So the data governance, so how to get data for AI, dynamic cloud edge deployment, so how to deploy, how to get the applications into the factory and to the users, and how the processes look, and how you can enable SMEs to do it. And of course, how to create industrial AI, which fulfills the requirements regarding safety, robustness, and resilience in manufacturing and in production environments. Because if you look at commercial AI products, if your Alexa assistant or whatever AI you are using is predicting something or telling you something which isn't completely correct, it's in most cases not a big problem. But if you have an AI running which is taking care of your process control, in some cases this can be dangerous to the health of people. Of course, this is a safety concern, but of course also costly if you produce scrap and don't notice it because your AI told you everything is going fine and the final product is broken. So data governance, which is one of the first spots and basically also one of the biggest gaps we see in applying AI in manufacturing, because everyone here should know and be aware that we have this heterogeneous landscape of ICT technology in manufacturing, all these historically grown systems. And the problem there is that, as Stefan said, we cannot buy everything new. We have to try to improve this data governance, how to get data, and this is basically the part of the availability. If you look at the picture on the right, so how do I even get to the data? And how can I bring this data to AI applications? Because at the moment, if we do AI applications in manufacturing or in, with our customers or in a factory, most of the time, 80% of the effort is spent on integrating the data, looking at the data, making sure that all the data sets are there, that the data quality is sufficiently reached, which is also a part of the data governance. And we want to scale back this effort from 80% to maybe like to 10 or 20%, so that we can spend the remaining 80% on the functionality and efficient use of resources and productive use of resources, and not always trying to acquire this information and data. And this is why we need to improve also these other fields of the data governance and the knowledge. We have to create systems where we can connect the knowledge from what the people have in their heads, what's in the machine, and what we want to create from it. Security is always a concern. Where is my data? Does it still belong to me? And how can I make sure that it doesn't leak out if it's sensible information? And this is also part of the sovereignty regarding data governance. There is also a publication which is I forgot to change it to the English name because it's also available in English. It's also freely available. It's AI, artificial intelligence in Industry 4.0. Basically, you have to just translate the title in English, and it talks about all these application scenarios. And one of their main gripes with why we aren't scaling or widely scaling artificial intelligence at the moment yet is because we are not there yet regarding the data quality. So what are basically the main outcomes we expect from our project? One of the main outcomes is the so-called meta kernel. So this is something, if you know how operating systems work, so the kernel is basically the very core of an operating system, which makes everything around it work. So we call it meta kernel because, of course, we are not the real operating system, but we bring together components which will make all this platform operating system work. This is the meta kernel. And for that, we need an AI platform and AI platform services like an AI engine, an AI supervisor. For example, the AI supervisor, for example, is a service which makes sure that you are able to deploy an AI-based application in your production environment so that all the resources for the compute power and the data are sufficiently available, so that you can make sure that you have a secure runtime environment and a safe runtime environment for your AI applications. And then we have the basic services, which are services which are supporting users of the system to integrate data. They will enable you to to integrate your components. They will enable you to onboard your own services. They will enable you to connect services with other services. So these are the basic services. And production services are specific services provided by service providers who develop AI applications for manufacturing applications, who will basically be the productive parts of the system and be used in the actual production use cases, which we are also developing with our partners. Then what another outcome is, of course, an overall architecture and a reference architecture. And one specific part which we are integrating in this architecture of what's the foundation of our architecture and on which we are basing the principle of our data governance on is the so-called Industry 4.0 asset administration shell. So everything which is not yet translated here. So VWS is Verwaltungsschale in German. In English, it's called Asset Administration Shell, and it's basically the upcoming standard for interoperability in Industry 4.0 and smart manufacturing, if you want to use an international term. And currently, it's being developed and finalized as a standard. Soon it will be brought into the IEC standardization, and it's basically a digital representation for every asset in manufacturing or in a factory or in a company. And in our case, we have our focus in this project on creating administration shells for AI applications, ICT components, and OT components. And this is a strategy how we want to reach interoperability between an application and various hardware components in a factory. And the third part is, of course, these hardware, these physical components of in a factory, we call them FabOS devices. So down here we can see like the slope going up, because we want to be able to provide maybe more simple AI applications for smaller companies like SMEs or companies who have a lot of legacy hardware. So for that, we are developing integration strategies and components and solutions so that they can onboard easily. Then we have like smart machines, which are machines which are being developed nowadays. Those are machines which are already capable of communicating via IP technology or have already integrated interfaces like OPC UA, which can be easily directly integrated, which are maybe already working with some sort of platform of some sort of which is provided by some manufacturer. And of course, the third part is the final goal on this pathway to reach a final state of FabOS is to have native machines. So a FabOS device which is capable to provide a standardized self-description based on the asset administration shell standard. Modern or future machines, or modern machines nowadays too, but future machines should be able to run their own AI services inside them. If you look at your smartphone, if you have a current generation smartphone, you will find that the new processors made by Qualcomm or Samsung or whoever, also Huawei, they have like AI accelerators inside them, and Google is also building the Coral accelerators for development boards at the moment. These and companies are already integrating them into machines, and we will see things like this more and more in future machines. So for that, we want to be able to be directly able to connect to these hardware components for AI and run AI application directly on machines, not only on the edge or in the cloud, but really to make the machine intelligent with the help of FabOS. Okay. So of course, we also thought about the market potential. So here is a small market analysis about what's going on. On the left, you can see the I think it was the IoT market, because of course this is a topic which is housed in the IoT department basically. it's a quite large market, and it will be also it will be steadily growing. And of course, the AI application market itself, only looking at software and data science applications, is also a large growing market. So. And here you can see the consortium for FabOS. So we built it like in a matrix structure, because we said down at the bottom we have our research partners. Every research partner brings in some specialty. We have also a lot of projects which are already ongoing or running, which are being basically integrated into FabOS. And because, as I said, over the last year, since all this Industry 4.0 discussion started, and also around 2012, when many companies started to think about cloud technology, there were a lot of projects regarding how to create cloud capable manufacturing, how to do cloud manufacturing, how to create smart machines, and all of these research outcomes will be basically integrated into this. Also things like the admin administration shell, which is also driven by the German industry, will be integrated. And for that we have also other companies on board. In the middle here we can see mainly companies who are data science or technology driven companies. So NXP develops embedded systems. Cisco is an embedded system developer for software, so an embedded Linux, real-time capable Linux. Zotac is developing legacy adapters for hardware like cloud plugs. NetApp is an ICT provider for mainly for, but they are now creating more and more hardware for factories, so that you can basically put your miniature data center next to your machine and collect your data on there. And Yuzu and Ascon, Advaneo, Cosmoconsult, AI4, BD, Compile, and Kanban, those are all data science companies who develop data science or data-driven AI technologies and applications. On the right side, we have network and community partners, because one of the main or one important part of the project is the open source community we want to build. So for that we have networking partners, the Eclipse Foundation, which you should know if you are a developer, from the Eclipse IDE mainly, but they do a lot of other open source projects. They are on board, so that we can basically bring the outcomes and the developments into this open source community. We have also the associations on board, like our IG Metall, and what's this? The Machine Tooling Association and the German Engineering Association, because these are topics regarding AI and manufacturing technology, which need to be discussed, especially with someone like the IG Metall, because we basically want to reach a factory which is mainly automated and driven by AI, but we want to make sure that people are still needed and basically can take part of more productive jobs and most of the things which are only wasted time should be done by a system like this. And at the top, we have the application infrastructure partners, Trumpf, Zeiss, Siemens, Nokia, Bosch, and Bayer, and especially Nokia and Trumpf and Siemens. They want to basically use this and develop components and for the system to deploy it for their own customers. And mainly Zeiss, Trumpf, and Bosch are providing use cases which we are implementing to test out the system and roll it out. And at the bottom we see a lot of associated partners who are basically also involved in the project and giving us feedback and bringing in their own requirements, so that we can cover a lot more requirements than those which are provided by partners at the top.
Daniel,
yeah.
This is Jens speaking. Would you please come to an end?
Yes, sorry, I wasn't looking at the clock, but I will be finished. So we are running 3 years. We want to push to the market quickly and build this community over time and also afterwards. And this is also part of our exploitation concept. So we are in phase 1. We want to build this open source community. Phase 2 will be to establish an association for these open source components. And maybe sometime in the future, when phase 1 and 2 have been successful, we will go into an international rollout. So thank you. And I hope if you have questions, you can put them in the Q&A as I learned. And otherwise, I wish you a successful, nice day.
Thank you so much. Maybe I start with a question. First of all, I mean, such platform, we all will agree on that this seems to be exciting. This seems to be very timely. And there was one question popping up in my mind. If we look to the classical platforms like software platforms, architectures like Android, or I don't know, the platform behind Twitter, whatever, there's always this kind of platform risk. And platform risk means even if it's open to use it, the key question always is who's responsible for the rules. So, and this would be my question. So I understood FabOS is an open platform, but what does it mean when it comes to data ownership, when it comes to platform risk, who's responsible for the rules, the protocols, etc., etc.?
Yeah, so basically, for example, the platform ownership, this is handled by concepts which we are adapting from the Industrial Data Space Association. I don't know if you know them. I think they should be quite known nowadays. We have one of the partners, Advaneo, in the project has already implemented their technology and they are applying them. So we want to make sure that all the data is always stays always with the company who provides it. So we make sure that the data sovereignty is ensured. And the other part is basically, you mentioned Android. Android is like an inspiration for this concept because if you look at Android, you have like these components which can be which follow standards and you can basically upgrade components and things like this. If you use the Android ecosystem, you can use applications on your Android device. And similarly, we want to do it in FabOS regarding who's responsible for the rules in the system. This is something which we haven't decided on yet because this is where we had this exploitation slide. There will be this there was on the right side were like 3 options. Either there will be a company which is basically something like the Industrial Data Space Association, which has also members who then decide together what the rules are, or there will be basically one company running it, which would be then something like a future Google, but in that case you would have monopoly, which I think is what companies want. So we want to follow more the open approach of an association with partners who then basically create the rules together.
Okay,
but it's not an easy topic, so we have to see how it works out. Yeah.
That's why I ask. Yeah, absolutely. So I think we do not have any more questions. So yeah, I would say let's come to our third speaker. Thank you so much, Daniel. And
thank you.
We will talk later on. We'll proceed there, our discussion. And yeah, our third speaker is Dr. Georgios Papapanagoudiakis. Sorry for the pronunciation. You are an entrepreneur, founder, and CEO of a Greek company called Emphasis DigiWorld. You have a PhD in computer science and more than 30 years of work experience in the global transformation market, so involving M2M, IoT, and mobile technologies. And you are an expert on sensor-based operational intelligence solutions for mining, cement, and manufacturing industries. So that's very Very cool, I think. And you will introduce us today a new solution called Sensor Mind 4.0. And yeah, the floor is yours. Thanks.
Thank you. Thank you, Jens, for your introduction. Thank you, all of you, for attending this presentation. On this session, I will bring another point of view of a small SME that works closely with its customers on digitization projects. And the focus will be on the mining industry. Although mining companies has a top priority to remain sustainable, they are losing money due to inefficiencies, huge inefficiencies because of lack of digitization. And especially in the underground mine operations, they lack of real-time visibility to support dynamic and smart decisions. Although the miners need the underground process re-engineering and fine adjustments in order to optimize cost and safety and remain sustainable, they are quite late in the introduction of digitization in the operations. This is true for a lot of miners, although there are exceptions. So operational real-time data becomes critical to support operations and maintenance in mining. Here it comes. Sorry, I think I don't have control on of the slides.
Can you please click the screen with
Yes.
the presentation with the mouse, and after that we use the arrows.
I just made it. That it doesn't work.
Okay, so I will control the presentation, and you ask me. Now it works. I guess it's you.
Oh, okay. There was a big delay, but it works. Okay, thank you.
Sorry.
This comes to our company, Emphasis Digital, and our concept for the digital transformation in the raw materials. So we are working on solutions from sensor data-driven operational intelligence. What we do with our customers is to acquire data from the field, in this case from mining operations, get the data and then transform them into business meaningful information, and then creating layers upon this of business knowledge and ultimately business intelligence in order to allow them to have safe and efficient operations. We are working on the technology side, so we design and develop and deploy the IoT and cloud solution for mining, but we pay a lot of attention also to operational processes and the business concerns of our customers. So we are working close with them to support continuous improvement and change. That means that how they can use digitization solutions in order to achieve their goals and optimize their operations. Because the one part of the problem is technology, but there is also another part of the problem, which is the mentality and the silos existing in companies. And today, in our point of view, you may see that the board of all corporates are very positive in digitization. Everyone wants to go to this direction, but the structure of the companies is not always adequate. So sometimes the decisions are quite difficult. You have to negotiate and convince and communicate the solution to the unions and be part of the full change and provide the right steps on the right time. And this is what we are doing closely working with our customers. So this is a portfolio of our solutions for the raw materials. We have the e-mining solution that improves efficiency, safety, and product quality in mining and essentially transportations, excavation. E-cement that improves efficiency, quality, and safety in cement transportation. E-meter, which is a platform for infrastructure, sensor data, and context awareness. This is the one that we're using in underground mining operations. We are developing IoT and also communication systems. For this specific solution that I will present to you, we have developed LoRa data communication for the underground areas. And also in order to optimize and provide the essential part of the digitization with the smart decisions, and get the information on the right person, the right time, on the right context, we are building also the mobile application to support it. Here is a typical and high-level presentation of our platforms. All of them, they have the same structure. On the top, there is the inputs, and on the bottom, there are outputs. On the inputs, you have two parts. The one is the real world, what's going on the field. We have sensors that provide data for localization, utilization, energy consumption, operator profiling. We get data from the field. On the other side, we have the business world. We have business models, contracts, cost model, operation schedules, and planning. So we are trying to combine both of those worlds in order to give meaningful information to two kinds of users. The one of operational support to understand the daily schedule and understand exceptions in a dashboard to manage operation, and also get notifications for handling exceptions, essentially safety exceptions, but also efficiency. And the other part of the users are KPIs. I mean, KPIs which are based on real data. They are not based on paper. They are based on real data that they're getting from the field, and you have very accurate KPIs that explain how the actual execution diverges from planning, what is the asset utilization, the contractual versus the actual cost, safety, product quality, and service quality. So this is the concept that we are using to all of our solutions. We compare the real world based on sensor presentation to the business world based on models, contracts, planning, and scheduling. And we understand how things are going, if they need some optimization and change, and if there are exceptions to want the right persons and get over to handle the exception. These are our customers, mainly from mining and industrial production. We have provided some examples of our solutions is on Lafarge-Holcim, which is a cement producer. We are providing in several countries a solution to supervise the safety of cement unloading. This is a bulk cement unloading. It needs pressurized air, and there are some safety concerns about this. There are also accidents. We have provided to them a solution who supervise safety or safety rules during the product unloading. Another customer in mining is Imeris. We have provided to them an e-mining solution which provides visibility in pellet and bentonite operations. So they are supervising seven mines and the ore transportation and ore logistics between them. And for aluminum of Greece, we provided a solution for ventilation in the underground exploitation they have in Parnassos, so ventilation system that I will present a little bit more on detail in order to present you one of our solutions in the mining companies. So the Sensen Mine 4.0 is a solution that provides ventilation on demand. Traditional mining companies, they have a ventilation system which is not optimized. They just working, provide the required air quality in the underground areas, which are quite, can be something like 3 to 5 kilometers from the surface running. And so its ventilation on these areas is very costly. Around 30% of the energy consumption in a typical mine, underground mine exploitation, goes to the ventilation. So on the other side, they don't have accurate measurements. Of course, they are doing auditing of air quality, but they don't have continuous and accurate measurements of the air quality. And now it comes to our solution, which is a ventilation on demand that optimizes the ventilation, considering operational status and environmental conditions, underground conditions. So the most important benefits of our customers there is to save energy because as I said, ventilation is about a third of the energy consumption, and we prove that they can prove they can save 18% of the energy in a case that we have already installed this solution to preserve the air quality on mining underground areas by continuously monitoring the quality. So this is a good news for the relationship with the unions, because they can ensure that the air quality is the right one in the underground areas, and also to comply with regulations, because there are regulations for the mining companies on European and also international level for the exposure limit of air contaminants. For example, for continuous exposure of 8 hours, the maximum acceptable level for CO is 50 ppm. Another point which is quite important for the mining companies is that the regulation is changing. So from the current regulation they have this year, there will be a change, a significant change in year 2023. That the rules for 2023 are more strict, and in some cases, as for NO2, are far more strict, can be 10 times more strict. So they need to adjust their ventilation system, and this is what we are offering to them with a solution that complies with the new regulation. This is a typical architecture of IoT and how it works in Sense and Mine. The particular point for the mine application is the underground network of LoRa cells. We have provided for this solution gas level measurements, which is an IoT device. Provides measurement for several kinds of gases, and essentially for each mine exploitation, there are other gases that should be remote. The one that I present here is for bauxite exploitation. Also, we keep data from the underground mining assets, operations, and engine running, and also control the ventilator operations. All the data are getting out of the underground area by a network of LoRa cells that broadcast the data inside the underground areas and goes to a gateway and then to the cloud, to a cloud platform where is the ventilation on demand server. All the clients are connected to, all the users are connected to the ventilation demand server through a web client and mobile interfaces. So they have direct access to what's going on the field in the mining areas. So currently we are working in order to expand these solutions and include other operation technology, OT equipment of the underground operations, like infrastructure monitoring, lighting, pumps, elevators, doors, and other kind of underground equipment, alert on fluid, fire and smoke, and also asset location and asset working cycle monitoring, operator location for safety, power management and metering, and airflow measurement. So the baseline is to provide an easy to deploy solution for underground operations. And currently also we are working to extend our air quality management platform to other customers, and we are looking for partners in order to extend the solution into manufacturing installations. So thank you very much for attending this presentation. I will be glad to answer to any questions you may have.
Thank you, first of all. So I'm just screening the video. No questions yet. So I will start with one. I was thinking of 20 years ago. So if we go back in time, I asked myself, what has changed? So you have a very successful platform for raw materials, and I'm not sure. So what is really the thing, what had changed over 20 years? Is it cost decline of sensors? Is it cost decline of computing power, or the cost decline of operating data networks, communication networks? Do we have better algorithm? Is it all together, or what does it mean? Why is your product now so competitive? Why is this, from a technical perspective, why is this so good right now? Wasn't that also possible 20 years ago, 15 years ago?
It's a bit through all the answers that you already give, Jens. But I think the most important that you didn't mention is mentality. What changed is the mentality of the mining companies, that they start to look into the digitization. I think the basic problem is the change. So the problem in mining is not only a technological problem, but also on how to deploy this into the operation, how to embed it, because they have a very rigid and very traditional and rigid structure. And so they cannot easily incorporate changes. And also another point of view is the cost or the maintainability of the solution, because mining companies' operations are far away in remote areas. So have a solution which can be maintainable. It's a very important point. if you give them solutions that can be excellent but cannot be maintained locally, this is no solution for them. So as we work very closely with them, we know how they work. So we have this opportunity and chance to build this part, maintainability, since the very beginning of our solution. So maintainability and integration to specific environments is a key solution. Of course, if we go to technology, 20 years ago, it could be possible. You could find somehow a way to control ventilation. But still, during all these years, the basic change was the mentality. And how to change the mentality and have the people accept a solution which is digitize their own work.
Interesting. And another question comes to my mind is the question of regulation and things like compliance. So we have the European Union, we have supply chains all over the world. If we now want to build, we will talk about this on the panel later, but at this point, it's from my side would be very interesting to hear about the regulation and the compliance requirements in this industry. So is it different now from the situation 15 years ago? This means do they have to provide plenty of data, plenty of data points? Do they have to prove them, etc., etc. when it comes to water, working facilities requirements, etc., etc.?
Well, the regulations that are currently currently comply the mining companies are the same that were 10 years ago. So there are no new. What will be new will be the new regulations in 2023, which are already published, and these regulations are strict, are more strict than the existing ones. Of course, the regulation, the companies today, they comply with the regulation by taking samples of air quality from time to time, but by handheld instruments. They have to send someone on the field, which is already a lengthy task, working task, and get measurement on the field, and then complete paper with the data, and then put it on the database, and so on. But in our solution, everything goes digital and automatically, and of course the sampling is very frequent. So there is no way to have exceptions in the air quality, and this is also a big change for communicating this solution to the unions.
And how about sharing data? If we heard about FabOS and how important it is to share data between different divisions in a company, between machines on that level, and also between, of course, suppliers, etc., etc. Does this play a role, or is it in the mining sector still like, okay, this is an isolated company with just the typical number of contacts with other companies? Hasn't that changed? So.
Well, I think the mining companies are not used to deal with this problem yet. Well, they are starting now. And in what concerns the ventilation and the air quality, our customers' point of view was to share this data and essentially share them with the union. I mean, that the union has access to the data, and because this is a good thing to prove that you have a good ventilation that provides a good air quality, and this improves the health and safety of your operators underground. And this is quite important for them. But if your question is more broad, I think I cannot answer from my point of view. Of course, legal also, legal bodies has access to this in order to ensure the that the ventilation complies with the regulation. But besides that, I don't see any further sharing of this data.
Okay. So what I had in mind, I'm not an expert on these industries. What I had in mind is the CO2 certificates or certificates of origin in these areas, because at the end of the day, all industries will have to contribute their part. So energy, what is my field, we see this definitely happening right now. And I'm sure in other sectors, this will pop up finally as well, right? Yeah, but we will talk about this on our panel. I think we have to hurry up a little bit. Thank you so much. And I guess it's now my turn to speak a little bit about the contribution of digital technologies to a more sustainable and competitive energy systems and the connections here to manufacturing. So I will try to get the power here. No, still not working. Okay, at least this was a reaction, wrong direction, but give me one more second. There is obviously a delay, so.
Okay, maybe I try to control it for you.
Yes, please. I don't know what's happening here.
Yeah, because you can turn back. Can you please? Yeah, can you click again on the presentation and after the forward arrow?
Yeah, do that.
Okay, I control it. Yeah, just for not wasting more time. So I get back to control.
Okay. So you can skip my first slide. Please, the next one. Thank you. Yeah, so I already did a quick introduction. I'm the head of a research institute in Frankfurt, Germany. My team and I, we work on the nexus of IoT, blockchain, AI, and green information systems. And over the last years, we did a couple of studies. One was a blockchain study for the German Association of Energy and Water Industries, which represents more than 1,800 companies. And recently we conducted a new one for the German Energy Agency. And that's where my research is located. And please, the next one. One thing we found out is that we urgently need a real-time energy economy. Why? Because we cannot cope with the complexity of millions of distributed energy resources in today's and tomorrow's energy system. This would be way too expensive. This is just the result. Please go on. And I could speak about that topic, of course, for hours. But I think here it makes sense to boil this down to two key elements. So first, companies, households, and communities are definitely today on track to invest considerable financial means in renewable generation capacity and storage. We already heard about today about storage and how important that is for industry, for decentralized energy management concepts, for households. And this means a shift towards a local, independently produced power. And this all will happen, or much, the bigger part of that will happen behind the meter. And behind the meter means the classical distribution grid operator is not, or the supplier, energy supplier is not responsible anymore for the devices behind this kind of meter. So it's a kind of frontier there that we have. And this means that this shift comes with a tsunami of devices that will be installed there. And it's not just energy generation, but also heat pumps, other loads like cars, etc., batteries. So transportation system, heating system, and this means that the electricity grid in 2030 will other units will own these devices. And this will complicate the management of distribution systems. And the only way out here is to integrate these DERs, these distributed energy resources, in order to prevent exploding network costs. This is one very important step here. And please, can we go on? But it's not all about generation. The demand side, of course, is also undergoing a fundamental change. I already mentioned heat pumps, etc., and cars, but there's more. So this is about manufacturing, etc. What you can see here is the search engine showdown, and this showed already that we have more than 20 billion devices with internet access. And this is not a forecast, this is real empirical data here. So please, the next one, next slide. So billions of devices with internet access means active endpoints in the energy system. We already have more than 70 IoT platforms in place, providers like PG&E, Siemens, Cisco, Schneider, a lot of them, and they all want to get usage data and send control signals back. So we definitely will see more and more fluctuation on distribution grid level, and this has a serious consequence for the energy sector. We will see rising costs. The regulated part of the, at least in Europe, of the energy system means we have to install a lot of backups. Stefan already talked about that, sorry. Can we go to the next slide? So we suggest that we want to open the energy system and then try to imagine a digital real-time economy with a high frequency trading of billions of devices and a high utilization of the grid as well. This means a battery in a company, for instance, that can switch between self-consumption, energy-only markets, trading, wholesale markets, and ancillary services for the grid services. And this is possible in seconds. We already have shown that. We have a lot of experience right now with a lot of ongoing research projects on the European Union level and also in the US or China. This is happening, and this is already possible. Can we go to the next slide, please? The question remains, how can we put this plan into practice? So what are the challenges here from a technological perspective. In a nutshell, I would say technologies like blockchain, like 5G, machine learning, etc., they all allow us to have a kind of horizontal energy system with a high degree of competition and innovation. Because these technologies bring down the cost for using the market. This is what we call transaction costs. In former times, 20 years ago, we didn't have a liberalized energy market in Europe, or in the most countries in Europe. This was the typical vertical integrated energy system. We opened that up, and now we have we have a lot of transaction costs because we have costs for using the market, and horizontal energy systems, they are usually, we have then all of a sudden many interfaces between the actors. So for give you an example, in Germany at least, we have 1,000 energy suppliers, electricity suppliers in Germany, and they have to have the possibility to exchange data. And this means an intersection, an interface there, and this means transaction costs because you need interoperability there on this level. The thing is with blockchain, with IoT, with new information systems, etc., we can bring these costs down if we can achieve a good good quality of service here, if we have standards, if we have open system, and so on. Can we go on, please? So let's jump to an example here. If we ask how digital the energy sector is today, I have here an example from Germany, but we could go to the UK and we would see something similar. So the system still is not that digital, the energy sector. Why? Again, imagine this battery I mentioned. If you are a battery in Germany, it's not possible to switch in seconds or in a minute or even in a day between your different market roles, like self-consumption. You are in a company, you have a backup battery, and you want to deliver to the market or to give grid services access, a DSO access to your device. It's not possible today, not only from a regulatory side, but also from a technical side. We have you see on the right side here, this kind of asset registry. We just started that in Germany. The UK is following, but not a centralized one. So the question is, we have on the left side, smart meter gateway, typical meter, and then a communication unit on top. The German one's pretty special, but in general, it's the same. And you have the asset registry on the other side. In general, it would be very easy if you say you have an end-to-end automated system, you have a device like a battery, and then you say, okay, I can link my device, I can show who I am, authorize this device via the smart meter gateway to the asset registry. Today we do this by a document, by a formula. This is crazy. And then send it by a post or over the internet, it's just you fill it by hand. But still you cannot change. So please, the next one. And what really important about this example is, one reason for this missing link situation we have is the internet in itself. In today's internet, we cannot exchange digital goods without an intermediary. Why? Because I cannot keep you from copying a photo or any file. And this is indeed a problem because intermediaries are always expensive and a dangerous single point of failure. So, please go to the next slide. We came up with a blockchain-based asset registry for the German Energy Association and 20 partners. And the idea is to use kind of trusted computing modules or other pieces of hardware-based security to actually prove what the device behind the meter is doing. Just talking about a device ID. Yeah? So if we can build a trust chain from a battery in a home or in a company behind the meter to the actual smart meter gateway to an asset registry in an instance. This is the goal here. And blockchain technology is one technology to do this, to bring this into action. But for me, it's important that we try to do this. So please, the next slide. From October last year until this month, we developed a concept for a pilot with 19 partners from industry. And the German federal government has commissioned the German Energy Agency and my team to build a prototype. And we will see how this will go on. Please, the next one. So for our discussion here, I think it's important to stress that one way is the exchange of data between market actors in a secure and direct way without the need of an intermediary, because we are then able to automate entire business logics. And we then can prove every computation step even between strangers here. This is the promise of blockchain, of distributed ledger technologies. And I think, please, the next one, the last one. Can talk about in detail what is the different approaches, the technology behind that. But what I can talk about is that we all know that, or at least I showed that energy markets could profit from real-time data. And we heard that in other industries it will be similar. And for instance, we all use, in different sectors, we use data to train our models. If you can prove the origin of data, this would increase the quality of the data you feed in, you train your models with, in a very good way. This would be fantastic. And we want to be situation aware. Think about a battery, a heat pump, and an electric car. Today, if we talk about certificates of origin, if you talk about CO2 certificates, if you do not know at what moment the car got the electricity, and so when and the what, how much, of course, and where, you cannot really say how green the energy was. So for all these things, we need to give proof what happened, and this is only possible in a digital way. So we talk about CO2 certificates. If you want to build a green car, you have all the different steps, manufacturing steps. You have to show what kind of energy went into the car, into the production system when. What kind of CO2 risk do we have on different stages here? On the European level, it's still on the table, the paper that the big companies have to at least say something about their, from an attestation standpoint, about their CO2 risks. So my point here is we need machine identities, digital machine identities, and one way is to go here is with decentralized machine identities. And yeah, I think this would be very promising for all the sustainability approaches we will see in the manufacturing sector and in other sectors. So that's it from my side, and I think we can go back now. Let me see if we have questions. Otherwise, we would, immediately jump to our panel. So any spontaneous questions for me? No. Wonderful. Okay. So then I would say we start the panel discussion. Okay. Let me have a look to my watch here. Wonderful. Okay. Yeah, my first question goes to Daniel. Daniel, could you please elaborate on a little bit, what do you think, how can FabOS contribute to sustainability in general and the sustainability goals?
So the basic idea to support goals like this, which are like, how would you call them? Of course, there are important goals nowadays, but from a viewpoint of someone who only looks at automation technology, they are like Querschnittsziele. So secondary goals, but we think that by introducing more flexible OT technology, which is better reusable, which can be better upgraded, which can be better, quicker reconfigured, which can help quicker finding, for example, this example we had from Stefan on which you also discussed, if I find out where is the leakage and how can I fix it. So these kinds of applications, to enable them by making a system which allows me to monitor everything in real time, deploy AI technologies according to the needs. For example, specific AI services for energy efficiency or other things which can be relevant to sustainability. Then these are the building blocks which in our opinion can also help beyond just improving flexibility of automation technology, but also improving all these other things which are basically directly tackled by these technologies.
Yeah. I asked Stefan about effectiveness versus efficiency. And what I see with FabOS, what would be possible here, at least from my perspective here, is I talked about blockchain, etc. And one thing this technology can provide is, or what would change is that in data networks you would get stateful status. So today the internet is stateless. This means you cannot really prove that you send something, that you are, and so on. You know that.
Yes.
So with FabOS, what does it mean for a trust layer? So my example was this kind of certification. If you have how much energy, this was my example, but of course, how much, what kind of raw material, where did it come from, went into this product. So what does it mean for the trust layer and sharing this information?
So this is basically exactly one of the main parts which the admin administration shell of Industry 4.0 wants to reach, because it operates with so-called submodels, which can be services, which can be information models, which can be specific applications. For example, something like a blockchain supported service, which is encapsulated into this submodel, which belongs to a specific part in your manufacturing environment. So basically a machine can have a submodel which is blockchain supported, and this could be used then, for example, to prove the identity of the machine. And by providing this data through these unified, standardized interfaces of the administration shell, you can make sure that you have systems which are compatible with it and are able to extract this identity information from it. So this, as you said, could be one of the benefits of using something like a FabOS, because in our opinion, the administration shell as one of the core components of FabOS is something which is meant to be a driver for interoperability.
Yeah, thank you. Stefan has to leave. He will join another meeting. So I have another question for you. So in this moment, we know that the biggest challenge right now is COVID-19. And I would love to discuss with you, where do you see the influence of COVID-19 on sustainable manufacturing, and how this could affect the adoption of the technologies we talked about? You can go.
I think that
I don't know. Who wants to start?
Was this a question to me or overall?
It was a question to both of you. Sorry, okay. But go ahead, Daniel. It's no problem.
So this is, I think I mentioned this during my presentation, but I think this COVID-19 isn't really something, or how should I put it? It's something we should be aware of, but nobody was really thinking about it, because the last pandemic was like very local, or it wasn't. It was very endemic with SARS in 2012, and now with COVID as a pandemic, which hit the worldwide population and also all these countries and all these industry sectors at once, it basically created this awareness of this imminent danger, which is basically always there, always was there, and always will be there. So this will basically also, in my opinion, create a more open or a better openness towards technologies which were a bit ignored in the past years, because until now everything was only for, if you go to research, of course we always try to improve flexibility and reconfigurability, and these are all buzzwords which are used in research projects if you want to improve efficiency of manufacturing. And but if you look at reality, in most cases companies just want to have the most efficient setup to produce at the best at the lowest cost, so in most cases. And I think due to this pandemic, this awareness is now there. Okay, sometimes we have to invest a bit more in other areas, maybe invest a bit more in more flexible manufacturing, maybe risk that there is a bigger cost by using these maybe more expensive, more flexible technologies, but it will pay out in a scenario like this, which can hit any time, and then we will reap the benefits. And I think this is something where COVID has or will create or has already created a big awareness.
And how's the situation in the mining sector? Oh, you have to unmute. We cannot hear you. Thank you.
Okay. Jens, in mining, the situation is even more important in terms of the COVID-19, as the mining corporates need process re-engineering and fine adjustment to optimize cost efficiency and safety and remain sustainable. So this is true for several years now, and this is underlined by the board of the mining corporates. The COVID-19 crisis accelerates this process and makes that because they face a new environment with new production, with new use of resources, and also a new requirements from the customers. because the market requirements were varying and still varying, and the prices also of the ore is fluctuating. So for the mining corporates would need to reconsider operations, not only on the mining phase, but also for logistics. For example, having storage for ore which is not sold immediately to the customers. We saw this problem with the price of the oil in the US, as you know. But this kind of problem is true for every mine corporate under the COVID-19 crisis. So because of this, the digitization was more, let's say, advanced in order to provide a solution to them. So somehow they accelerate the COVID-19 crisis, serve to accelerate the introduction of digitization in the operations.
And does this include that they will do things totally different when it comes to sustainability goals? So I talk about, say, CO2 certificates, green products, etc. Because of course it's always one thing to use technologies like AI, etc. to make things more cost efficient. But it's another thing to use them on the next level to say, okay, I can prove now, I can better organize my processes. I can come up with totally new ways to do this. Or think about quality. I mean, if I as a supplier, I talk now about raw materials. I have no clue about raw materials, but if I can prove all the supply chain along that these components were compliant to all the SDGs, yeah, well, a lot of them. This could be at the end of the day, could be, okay, this is not only a green car, what we have, but also we have now a green car that is produced in a totally compliant way to other SDGs, working environments and so on. Do you think this is just something that has to be, so let's keep this example with the car. If Volkswagen say, okay, I need steel, just green steel, okay, then we have to look the entire supply chain down. Do you think it's a bottom-up thing or a top-down thing? Somebody has to push or somebody has to pull? What is happening right now?
I think the truth is somewhere in the middle. But I cannot answer for all mining corporates here. What I can see is that the COVID-19 crisis highlighted some concerns relative to health and safety. So the corporates are more sensitive in health and safety of their operators, but also on the environment they are working and the environment in the large sense of the community. So CO2 emissions, for example, is part of this. Dust and PM 2.5 material, a particulate matter, is also a high concern today because of the COVID-19 crisis. And the overall health and safety of the operators in the operations is also a big concern. So somehow they are pushed in order to find solutions to these problems. They feel that there is something more than the one that was before the crisis.
Okay, thank you. So one last question, and this goes to Daniel. We heard about the mining industry and the mental change. You mentioned that. And this, I think, is very interesting. So when it comes to the product FabOS, the platform, the software platform here, do you think that all the different manufacturers in Germany, do they really embrace this idea in the sense of, okay, now is the the right moment in time to do this because we have a crisis, etc. So 1 year ago, most of the companies, small and medium-sized enterprises I talked to, they said, oh, we have no time for that because we have to manufacture so many things, so it's a problem. Now we have the crisis. Do you think it's a good time right now to go ahead?
Possibly yes, because as you said, until now, all the companies were in a mode of very interesting, thank you, but we don't have too much time for these research-intensive tasks. But
I mean, now they could say too expensive for us, right?
Now they could, of course, now they have the monetary problem in some cases, but what we already see now is that our government is now starting to providing special funds for research. This was already the case in 2009 after the crisis, that there was additional funds being provided by the government for to basically support companies who wanted to reorient or bring in or to bridge these crisis gaps. And we already see something like this coming up now for this crisis. There are already some projects in the pipeline now, which will be coming in the next few months, specifically triggered by COVID. So by there is one project which is specifically aimed at supporting companies to reconfigure their production, as I mentioned already, for different products, for example, medical products. And in this case, companies who are willing to do this now have an additional possibility to get funding and to do research in this regard. So this is where we see a new additional possibility to get more companies on board with these topics.
Thank you. Thank you all so much for joining us. I think we will close now the panel discussion. We now have our brokerage session. We will start that. And this is a kind of matchmaking session so that we can get in contact here, know each other better, and yeah, let's start that. So who's first?
So we have Jojo from Bea. Can you please unmute yourself?
Hi everyone, can you hear me?
Yes, please go ahead.
Okay, wonderful. So I'm George Suciu Jr. I'm the R&D and Innovation Manager of Bea. We are a SME with around 80 people now. We started as a spin-off from the University in Polytechnica of Bucharest. And now we have professionals, so engineers in various domains like electronics, computer science, telecommunications, and we developed our telemetry solution, which means sensors that transmit data to the cloud. And we have several customers in different domains, also in the environmental domain, also in the industrial, also in health, also in agro-food. And we have also good experience in research projects. So we finished over 40 projects. We are currently running around 20 research projects, not only in Horizon, but also in the Eureka framework, ERANET, and some other frameworks. And we have good experience in the technical part with innovation in the data processing, also in the sensing. We have also a team that is doing speech and natural language processing using various machine learning algorithms. And we have also good experience in leading projects or parts of projects. And we are looking for SMEs, R&D performing SMEs, or research institutes or universities for the upcoming calls. Thank you very much.
Thank you very much. I will pass through. There is here some from Comau. Please raise your hand so I can. Someone for Comau, please raise your hand so I can get you for the speakers panel. I guess it's not here. I can identify Gianluca Pico. No. So we have to move forward. We have here Goran from City Gecko. Someone for City Gecko? Okay, I will move. Oh. So, Sally, can you please activate your sound? Sally heard from Regent. You are here? Okay, I guess. Can you please activate your sound and mute yourself? Sally, can you speak, please?
Maybe he's not available.
No, it's on the speakers panel, but it's muted, so we can hear. Maybe we have to move forward. Maybe
he can't hear you. He is not in the room.
Okay, so the next one is Sergio Pereira from University of Coimbra. Are you there? Sergio Pedro from University, are you there, please? Okay, I guess we don't have anyone else, so I pass the word for Jens.
Yeah, sure. This is
okay.
But yeah. So then we have just want to mention again, all of you have the opportunity to participate on the final public policy and funding opportunities plenary on May 29 at 11 o'clock. And yeah, hope you could enjoy the session and have a wonderful day.